let's jump right into today's deep dive. We usually think of memory as a single giant filing cabinet in our heads,
Yeah,
right?
exactly. You just toss a name in and hope you can find it later.
Right. But if you look at the multi-store model, the research suggests it's actually much more like an assembly line with very specific stations.
That's the perfect analogy. The multi-score model frames memory as a system with three distinct stops: sensory memory, short-term memory, and long-term memory.
And info has to survive the first two to get permanently stored in the third.
Right. You pay attention to move it from sensory to short-term. And then you use maintenance rehearsal, which is basically repeating it over and over, to lock it into long-term storage.
So that's our mission for this deep dive. We aren't just tracing the flow. We are popping the hood to look at the actual mechanics.
The specific constraints.
Exactly. We have data on three key metrics for these stores. Capacity, meaning how much they hold. Duration, or how long info lasts. And coding, which is the format the brain uses to write it down.
And the constraints on that first major stop, short-term memory, are tighter than most people realize.
They really are. Take capacity, for example. There's this classic digit span test where researchers read lists of numbers and letters to people just to see where they maxed out.
And they found the average limit is about 9 numbers or 7 letters.
Which gives us that famous rule, right? The magic number 7 plus or minus 2.
Right. That's the limit of your mental workbench. If you try to hold 10 distinct items in your head right now without grouping them together, things just start falling off the table.
But the capacity isn't even the biggest bottleneck. It's the duration, because it is incredibly fleeting.
Oh, yeah. There's a fascinating study that nailed this down using nonsense trigrams. Random 3-letter chunks, say XQF.
But the clever part was how they stopped people from cheating. They showed the trigram and then immediately made the participants count backward.
Because that prevents maintenance rehearsal. It stops you from looping XQF over and over in your internal monologue.
And the drop-off is brutal. Without that rehearsal loop, accuracy was at 80% at just 3 seconds.
But then it plummeted to around 10% after 18 seconds.
So without active repetition, short-term memory just evaporates in less than 20 seconds.
It really does. And there's one more specific mechanic to short-term memory, which is coding.
Right, how the info is formatted.
Exactly. Researchers found that people really struggled to distinguish between words that sounded similar, words like cat, mat, and hat.
Which tells us short-term memory is acoustic. It records the sound of the information, not the actual meaning.
But that is where the assembly line changes completely.
Right. Once you get info into the vault into long-term memory, the rules of physics seem to flip. Short-term is acoustic and fleeting, but long-term is semantic and permanent.
The duration stats for long-term are just staggering. There was this yearbook study where they tested people on identifying their classmates.
This is one of my favorites, actually. People who had graduated 14 years prior could still recall about 90% of their classmates.
And even 47 years later, accuracy was still hovering around 60%.
Which suggests the duration of long-term memory is effectively a lifetime.
A whole lifetime, yeah. And unlike that 7 items limit in short term, the capacity here is potentially unlimited.
And like I mentioned, the coding flips here too. While short-term gets confused by similar sounds, long-term gets confused by similar meanings.
Right. If you're pulling from long-term memory, you're much more likely to mix up big, large, and huge.
Because you remember the concept, the semantic meaning, even if you lose the specific acoustic label.
So we have this really robust architectural model. Short-term is the acoustic scratch pad, and long-term is the semantic library.
But we do have to look at this critically. A lot of this foundation is built on memorizing XQF, or lists of random digits.
Which brings up ecological validity. It's the scientific way of asking if this actually happens in the real world.
Right, because memorizing nonsense syllables in a silent lab is a weirdly specific task. It doesn't necessarily reflect how you remember a conversation with your boss or the plot of a movie.
It's a very valid limitation. By stripping away meaning to test the raw mechanics, these studies might be creating an artificial picture.
Sure, we struggle with random digits, but we are evolutionarily designed to remember faces and stories and threats.
Exactly. It's like testing a Ferrari by driving it in first gear in a parking lot.
You get data, but you don't really know how it handles on the highway.
Precisely. The model gives us a great structure, but it might be too rigid to explain the messy, meaningful way we actually live our lives.
So here's a final thought for you to mull over. If the foundational research of our memory models is built almost entirely on artificial tasks like nonsense words,
Yeah.
are we vastly underestimating our own mental capacity simply because we've never been tested on the things that actually matter to us?